lesson 1-4. Our learning goal. What are we going to learn about today? We're going to learn about key characteristics of polynomial functions. What does polynomial mean? Many. So we'll have many terms. This is going to be like where you have multiple terms. So that's what we're going to look at today. So let's get started. We have a lot of vocabulary to go through. First, here's a polynomial, and we're going to say this is the general form. Okay, the general form, or standard form, you could call it, is written this way, where when you look at the powers, if you have it lined up, you put it the powers from highest to lowest. So in this case, if you looked at this function here, what value would have the highest power?
First one.
The first one, because as you go down, if this is n, what's the next power? N minus 1. Now here's some rules about it. This is called the leading term because it's the highest power. Highest power, which the true name for that is degree. Highest degree, I'm going to write the word degree here, and then I'm going to put in parentheses power. So you know, what is a degree? It's the highest power. That's called the degree of the function, okay? An is the leading coefficient, n is the degree. Oh, it's right here. N is the degree. There it is. Make sure you draw, that's a word you're going to see a lot, degree. The word degree means it's the highest power. A0 is a constant. What does that mean? Does this have an x? No x value. No x value with it. This would be for all these being real numbers, the a's in the front, the coefficients, okay? And the domain is a set of all real numbers. Now, why is that? Now, we talked about this. What are the things that break up the domain? The domain is all reals unless you see cannot divide by 0. That was one of them.
Oh, there. Nothing can divide by
Can't divide by 0. Negative square roots. So negative square roots and a log. Now, here's the deal. In polynomials, you do not have logs. You're not allowed to have negative exponents, which would mean divisions. Negative exponents is the same thing as dividing by power of x. And finally, you're not allowed to have fraction exponents, and that's what roots are. So because you can't have a division, you can't have a square root, you can't have a log, this would always be all reals. So what are polynomials functions domains always going to be? All reals. All reals. You got it. All right, so here we go. Looking at this problem, I know it's written on your paper. Just written there so you remember. What do we call this first term right here? The leading term. If I said, what's the leading coefficient, you would say 3. If I said, what's the degree, you would say 5. If I said, what's the constant of that polynomial, the answer is not the constant. There it is, -6. That's the constant. Okay? You can read through that as well. There's some notes on there, but just we're going to look at examples. So example 1. Determine whether each of the following functions is a polynomial. Explain your answer. On number or part A, what do you think? Polynomial or not polynomial?
Not polynomial.
It's not. For 2 reasons.
No constant.
There's a fraction in it.
Not polynomial. I heard one reason is we have a fraction power. That's one reason it's not polynomial.
Negative square root. Yeah, but no constant.
And the other is actually, it's not because of the negative power. Sorry, one reason. Why are we okay with that negative power? What's different?
It's not a fraction.
There's not an x.
Oh.
What a negative power means is you move it to the denominator. So instead of this value right here is actually the same thing as 1 minus 9 squared. That's when you have a negative power, that means you move it to the denominator. The negative 2 power is connected to 9, so the 9 moves with it, and you replace with the 1 up top because there's nothing else left over. What is 9 squared?
81.
So this would be like minus, whoops, started right to 81 first, my bad. This would be the same thing as minus 1 over 81 like that. So that would be fine. You could have that as a y-intercept, a constant, but the 2/3 power is what makes it not polynomial. All right, let's move on to B. Yep, we're just determining if it's polynomial or not. What about part B? What do you think? Polynomial, not polynomial? This is polynomial. Why is it polynomial?
It doesn't break any rules. It has no fraction power.
Okay, you don't see any fraction powers?
No.
Do you see any negative powers?
No.
No. You could simplify this by, what's it called when you multiply through a parentheses? What do we call that? Distributed. And you could write this as 2x cubed minus 3x squared. On this one, just a couple things to point out. What's the degree on part B? Not 2. It's actually 3, because when you distribute through, the highest power is 3. What's the leading term?
2.
2x cubed. What's the leading coefficient? 2. You hear all the different vocabulary. Coefficient means just the number in front. Leading term means with the x and the degree. Degree means just the power. So let's do it one more time. What is the leading coefficient? 2. What's the leading term? What's the degree? 3. What's the constant if you don't see any number by itself? 0. Well done. All right. Let's go to C. Polynomial, not polynomial.
I'd say not polynomial.
Not polynomial, I agree with you. What do you see?
We're dividing by x squared.
You're not allowed to have powers in the denominator, which means negative power. So that right there, that x squared, is the same thing as a negative power of 2. So that's why I'm going to put it down here as a negative power. Now, does it look like a negative power? No. It looks like a division by x squared. But that's the same thing as, you could rewrite that as 4x to the negative 2 power. Those are one and the same. 4x to the negative 2 power is the same thing as 4x squared. Now notice that 4 does not get the negative 2 power. Because the 4 was in the numerator, it would only be the x that gets the negative 2 power. So that's not polynomial. All right, what about D?
It is a polynomial.
No. So what's it mean to be a root? That means you divide by the power. This cancels this symbol right here. What does that cancel? What type of power? Squared. So I'm going to add in a little 2 here. That means you divide by the power 2. So another way of rewriting this is you could say this is 3x. The x is to the first power on the inside. 3x to the 1/2 minus 7x to the 1/3. You got it. Well done. 1/3. Now, they don't usually show you the 2 on a square root. It's assumed. They don't show you a number there. It's a 2. But they will on any other power that it divides by. That's right. Not polynomial. Fraction powers. I forgot to put that. Sorry. Fraction powers. Fraction powers. That's the reasoning. Okay? And I have one more on this slide.
Not polynomial.
I hear
No. Not polynomial.
Rain is right. What is it? It's a polynomial. Now, we need to actually add one thing. But why is it polynomial? If we simplify, what's x cubed divided by x?
X squared.
X squared. You could rewrite this as x squared plus, okay, the next one has a negative power. What's it mean if it's a negative power? Typically it means, if you see that and it goes to the denominator, it's already in the denominator. So where would this actually move? Up to the numerator. So it'd be x squared plus 2x squared. What happens with a square and a square root?
It cancels out.
Plus x. And do y'all know what anything to the 0 power is?
0.
No, it's not. It's 1. And here's the reason. If you think of it this way, 10 divided by 10, remember how we subtract powers? That's the same thing as 10 to the 0. Oh, there it goes. It was just slow. Sorry. 10 to the... What? 10 to the 0. There we go. And what is 10 divided by 10? 1. So that's the y, if you're wondering. That's why anything to the 0 power is 1. It's because it's like canceling itself out. So this would be plus 1 there. And that is polynomial because we could rewrite that one more time. What is x squared plus 2x squared?
2x3?
Not 2x.
3x.
You have an x squared and you have 2 more x squareds. Is that x to the 4th? Or is it 3 of them?
3.
It's 3. We're adding, so it's 3x squared plus x plus 1. Now this one you should do domain restrictions because we had a division here. What are you not allowed to divide by?
Oh, negative.
0.
0. Not allowed to divide by 0. So x could not be 0. And then in here in a root, what are you not allowed to take a square root of?
3.
Not 3.
Even. What, negative number?
Negative numbers. So this right here at the front says you cannot be 0 and x is by itself. If x is by itself cannot be negative. So what numbers can x be?
Positive.
Positive. You would need to write that here. X can only be the positives. Now, is it true that f of x simplified to this? Yes. But this was the original equation, and that would be domain errors. Okay, so because of that, we have the domain restriction. Let me write that in your notes. That might be good for you to remember. What is that? That is a domain restriction here. Domain restriction. Now, a polynomial is supposed to be all reals. So you can argue back and forth of, well, is this a polynomial then if it's not all reals? Well, for that reason, I'll do question mark. You can argue about it all you want, but this will not be an AP question like that because a lot of people argue with this. Is it polynomial when you simplify? Yes. But is it all reals? No. So what is it? Anyways, so I'll leave it like that. Do I have you good and confused?
Yes.
Good. All right. So what do we look for generally for polynomials?
Numbers.
What type of numbers? Or what are you not allowed to have?
We can't have negative numbers.
Where? Never on the problem anywhere not allowed to have negative?
Just in the denominator.
Look in the powers. No negative powers.
No negative square.
No fraction powers?
No fraction powers. Wait, you all right over there? All right. Let's make sure we're up. All right. So now, let's talk about this. We classify types of polynomials by their degree. What does that degree mean again?
Power.
The highest power. Okay. So, by the way, a graph of a polynomial should be, where's the word? I'm looking for it. Oh, it's already online. Smooth and continuous. That means you shouldn't see breaks. Because, again, we think of the domain being all reals, there shouldn't be breaks, and nor should there be hard turns, stuff like that. So the first one, polynomial, not polynomial. But not polynomial. This would be called piecewise. Oh, well, great. You can do NP or N. Okay, what about the second?
Polynomial.
This is polynomial. This one is polynomial. You can write it out, but since I already started, I'm going to continue on. Okay, what about part C?
Not polynomial.
Why not?
Because there's like a hard stop and then it just. Like
These cusps.
Yeah.
Yeah, not polynomial. Now it's weird how they called one a cusp and one a curve, but I'm just going to call it a cusp. And D. It's polynomial. All right. Some key features. Come on, Chris. The domain. What do we say the domain is? All real numbers, which is symbolized here. It's all reals. Zeros. What are zeros? X-intercepts. I'm highlighting the words you need to have on this, so you can just kind of mark your notes as well. The domain should be all reals. And as this is saying, I forgot to say this on if it's a real-world solution, you might have a polynomial type equation, but the domain might not be all reals for a situation. Let me give you one. Let's say Nike makes shoes based off the equation y equals x cubed minus 2x squared plus x plus 6, where the X is the month of the year. During basketball season, they make more shoes. People are buying a lot more shoes when they're playing basketball. During summer season, people are buying flip-flops. They might not be buying sneakers. So they follow this equation. The equation I gave you was polynomial. Will, if you graph that, you might have some negative portions. Will Nike ever make negative shoes?
No.
No. So that would be a part where you might restrict the graph to months 0 through 12, or 1 through 12, if you will. You might restrict the graph and take away all the negatives. That would be an example. So we can't have domain restrictions if it's a real world. Okay, how about this? Increasing. What's it mean if it's increasing? Which way does it look if it's increasing?
Right.
It might not be. Okay, increasing means it's going up and to the right. That's an up and to the right. It does not necessarily mean it's concave up, though. I'll give you an example. This function right now, is that I want to just stop there. Is that concave up or concave down?
Concave down.
It's concave down. It's, you see how the slope's decreasing? The average rate of change is decreasing. But is it increasing or decreasing overall? It's increasing. So it doesn't mean concave up or concave down. It just means the graph's going up and to the right. Decreasing would mean not to the left, down and to the right.
Oh.
Okay, now concave up.
Yeah.
Does concave up look like it holds water or it's dumping water? Holds water. So we'll go like that. Concave down.
Drop.
What was an inflection point? Y'all remember?
That's
It
where
was
where it goes from the counter.
Alright, good. So on here I'm going to just draw like this. How many inflection points did we just draw there? Alright, how many do I need to add in?
2, 1.
Let's see. What's happening right now? Concave down. What happens here? Up. So in there we have a inflection point. That would be an inflection point. A relative or local maximum. What is that? Do I have any of those on this problem? What would this one be right there? Let me come back and write it up. That would be a relative max. There it goes. Relative max. And we also have a relative minimum. When it says relative, that does not, it means it's not the highest point on the entire graph. Is there something higher than this point on this graph?
Yeah.
Yes. That's why it's relative. Global would mean if it's the very high. So like a parabola always has a global maximum or minimum. So a parabola always has an absolute lowest point or an absolute highest point, and that's called global. So what's relative mean? Looks like a max, but it's not the max of the entire graph. Global means the highest point or the lowest point in the entire graph. Okay? They use the word absolute here. Absolute's the same thing as global. So write the word in here, global, on these. Global are words you might see. When we go over the AP question tomorrow, not tomorrow, whenever I see y'all next, whenever that is,
Monday.
you'll see that word global come up. So you need to remember what global means. That'll be part of the questions. Okay? I think, is that all the vocabulary? Are we ready? Perfect. All right, so picture, describe it. All the things I've been talking about are here. That's just for your viewing pleasure. You can go back. Okay. You can go back anytime and look over that. It talks about all those values that we've been dealing with. All right. Let's look at example 3 here. It says, let's take a look at this graph. So open up your calculators and we're going to graph this. I said you did.
No,
You
when
did
we
need
first got
calc-
here, you said y'all won't need calculators that much.
Oh, I was lying to you. First day, it's just lie. Lie to students first day. That's not true, but that's what happened. Okay, go to your graph. Let's graph this equation. You have it on your packet, so I'm not going to go full screen here. X squared plus 4x. And again, I'd recommend every time to clear the calculator out. It'll just help you to have a clean screen. We're only looking from 8 to 4. From the values 8 to 4. Now, I can't quite see my whole graph. Do y'all remember how I told you to change it last time?
Yeah.
To change this value, just double-click the bottom. How low do you think we could go to be pretty certain we're going to see the whole bottom of the graph?
-8.
29.
How about maybe negative 20? Do you think negative 20 will work?
Yeah.
Hit negative 20. Do we see it? All right. Now we actually need to be able to see to 4 and to negative 8 as well. So I'm going to go higher up here. Let's just stay consistent. I'm going to go 20 up top as well. So I'm changing my y-axis to those points. All right, what I want to do for you here is there's some buttons we can press to find some key values. Go to Menu.
How'd you do that? Like, what's it?
Okay, I will go full screen. Oh, what I did first is I double-clicked on the number. You just double-click and you type what you want on your axis. Okay? We're going to go to Menu, Analyze Graph. That's correct. What are some values that are going to be important to us? Minimum. Let's go minimum. What you do with this line is you go to the left of the minimum, click. You can click the center or you can press Enter, and go to the right of the minimum. And again, click or press the Enter key. I'm getting -2, -16. Was that the value you got?
Yeah.
All right, great.
Yeah, -2, -16.
Yeah, there were some other values that are important. This one we don't have to analyze. You should be able to see it here. What are our zeros at? 2 and
2 and -7.
1, 2, 3, 4, 5. I would say -6. But for the sake here of just practicing with the calculator, I'll go ahead, Menu, Analyze Graph, hit 0. Go to the left of that first 0. Go to the right. It'll give you the point, and then do it again. Menu, Analyze Graph, 0. And I think this will be almost all the points we need. There will only be one more point that we need. For a second, I'm going to stop here. Sorry, let me get this over. Let's see if this will cooperate. There we go. Okay. So let's fill in the values. This has zeros. Where are the zeros? The zeros are -6, +2. I agree. You're supposed to write x equals -6, +2. What do we call this -2, -16?
Absolute minimum.
Relative or absolute?
Absolute.
I'm going to go to absolute. And I'm going to put it there. Now, this graph is only supposed to go from -8 to 4. So we're looking kind of in this interval. Actually, let me do it this way. I'm going to use, I got a tool to make it a straight line, so why don't I use it? We're only supposed to be looking from -8 to +4. And, sorry, I'm going to do one more line. Bear with me just a moment longer. Good, I hit that one pretty well. Okay, so we're looking in there. From where to where is it decreasing? I'm going in order of the chart over there.
From -8 to -2.
Very good, -8. Why'd you not say negative infinity?
Because Because the graph doesn't go all the way down.
Because we had this restriction.
Yeah.
Because we were restricted. Because we are restricted, we're not going to go from negative infinity. We're going to say it's decreasing from -8. Actually, increasing, decreasing, you don't use brackets. I'm sorry. The increasing, decreasing, you only use parentheses. From -8 until, you said -2? Okay. Is the graph ever increasing? From where to where? -2 to 4. Good. So you just use parentheses on that. Is it concave up or concave down? From where to where?
From negative to the infinity. Oh, I mean negative to the 4.
Okay, now this I think they actually use. They might not use brackets. I can't remember. Let's just be consistent. I'm going to use parentheses. I might come back and correct this later and say, actually, for concave we do. Where is it concave down?
Negative 8 to -2.
So there's a spot where it's dumping water out?
No.
No.
No. So what do we do if there's nothing? You do n dash a. We're going to do that. And then finally, inflection points.
None.
None. There's none because it doesn't switch from concave up to concave down. Okay, so for relative minimum, I'm just going to write the word, we had an absolute. So I'm just going to write that word in. Absolute, so we flip there. Do we have a maximum?
No.
We do.
Well, wait.
So here's what's tricky. When they cut off the graph, if they have a restriction, the restriction points by rule can be counted as a maximum or a minimum. So this point where they cut off the graph, these would be considered the maximum of the graph.
Absolute.
It's an absolute maximum. How high does it appear to be?
20.
20. We're going to check real quick. Let's plug in a number. What is 4 squared? We're going to do f of 4 to make sure it's 20. F of 4, let's see what that equals. What is 4 squared? 16. Okay, remember that this is 16 plus, what's 4 times 4? 16 minus 12. What's 16 times plus 16? 32 minus 12? 20. So we were correct. So we have absolute maximum. We have 2 of them. It would be a -8, comma 20 and
4, 20.
4, comma 20. They're both absolutes because they're just as tall as one another. Do we have a relative maximum?
No.
No, we only have absolute. All right. Any questions before I move on?
Nope.
All right, let's do the next problem then. Part B. X cubed plus 1 on the interval -2 to 2. Now this time, there's a way of doing this in the calculator, and I'm going to show it to you. As long as I remember how to do it right. Just to make sure, clear your calculator out. Hit home screen, don't save. I want to make sure it doesn't add any numbers it doesn't need on there. Because we added zeros, we added a minimum. Hit add a graph. Hit X. The button next to squared looks like a little up arrow. If you click that, that'll give you your power. X cubed plus 1. Now if I remember how to do this, you hit control equals. You see control equals has all these inequalities. This line means you're about to give a restriction. Okay, so hit that line. Where did I get that little line? Control equals. Now you're going to type, you can't use the brackets and parentheses. I don't believe that method works here. So we have to use inequalities. We're going to say -2 is, hit control equals again. If it's a bracket, does it mean less than or less than or equal to?
Less than.
Less than or equal to? We're restricting the domain, so put an X there. And then do it again. Control equals less than or equal to 2. Now I'm going to go bigger so you can see it on mine. Sorry, should have done that earlier. I just wanted to be able to see the problem. But
The line
X plus 1, where'd you get this? Where'd I get this line?
from control equals.
Control equals. And then as well as the inequalities also came from control equals. Type it in just like that. And I believe This time it'll cut off the graph. Does it? Maybe. Let's see. I'm going to change my y-axis. What number did we change it to last time?
20.
Let's try 20 again. Did it cut it off? All right. What should we change? 20 looks like it's pretty a lot higher than it needs to be. I'm going to go 15.
No, 10.
10 would work?
Yeah, 10.
Okay, I'm going to go negative 10 down here then. Negative 10. You're right. 10 would have worked. All right, what values do we need to use analyze graph for?
The zeros
Okay,
and the
let's do 0. So go to the left, go to the right. There's a 0. Go menu, analyze graph. What else could we use? Minimum.
Yeah.
We do have a, would this be relative or absolute down here? Absolute. Go to the left, go to the right. There's our minimum. Menu, analyze graph. Maximum. Any other points we need to find in here?
the inflection point.
It will be an inflection point. Do I have a tool for that?
I guess
No.
No.
No inflection point. So we can't do anything else as far as I know. So I'm going to take a picture of this so we can start writing on our packet with it. So hopefully you have those values. Let's fill in. Zeros. What should we put in the 0 column?
X equals -1.
0. X equals -1. Great saying that. You said it perfect. Relative maximum. Do we have a relative maximum?
No, we have an absolute.
We have just an absolute. I'm just going to say ABS. Do we have a relative minimum?
No.
No. To have a relative minimum, it has to fully change directions from increasing to decreasing or decreasing to increasing. The average rate of change changes here, but the graph never actually starts going negative. It's always increasing. It's not so. Just absolutes there. Okay, next one. Chris, make sure focus, please. Absolute maximum. What do we put for that?
2,9.
2,9. Absolute minimum.
-2,
-2, -7. Good. Is the graph decreasing?
No.
Never. It's strictly increasing. Where's it increase from?
-2, +2.
-2 to +2. Oh, I forgot to do N, A. Okay. Concave up?
Yeah.
It is concave up. From where to where? Where are we going to say the inflection point is?
You can say 1, 0.
Is that 1, 0 right there?
Yeah.
No, that's not.
That's 0.
That's 0, 1. That's 0, 1. So we're going to say it's concave up from, remember you only do x's on this.
Oh, so
0 to 2. From 0 to 2. Where is it concave down?
-2.
From -2 to 0. Inflection points? 0, 1. Good work.
Mr. Gordon,
Yes.
now,
Go ahead. Decreasing? Increasing? So the graph is always, from left to right, it's always going up. I know there's that inflection point where it looks, but it never starts decreasing. So you'd say from -2 to 2, it's always increasing, the whole graph. And so that was x values. That was not a point. If this is helpful over here, let's go back. These 4, these are intervals. I'll write the word intervals. The other values up there are the intervals or points. The maximum and minimum. Is that an interval or a point?
Point.
Point. The zero. Point. Inflection. Point. Yeah. The other is an interval. That might be helpful to put on this note as well. Go backwards. Come on. These four, decreasing, increasing, concave up, concave down, these are all intervals. So when you look at the answer, those are intervals. Okay. Let's try this a couple more times. Got two more examples, and then you'll have some practice. All right, so here's your equation. I'm going to switch over to calculator mode. So this time you can see me typing in bigger. X cubed minus 3x squared minus 4x. So y'all can remind me, you have it on your packets. Okay, I'm going to clear my screen. So home screen, new document. I'm not going to save. I'm going to add a graph. It was x cubed. What happened after x cubed? Minus 3x cubed squared. What? Sorry, forgot to leave the power. Minus 3x squared
Minus 4x.
minus 4x. What's the constant on this problem? There is no constant. It would be 0. Okay, how do we do the restriction again?
Put the control.
Control equals?
Put the line.
Put the vertical line. Now, I didn't even look at the numbers. What are we restricted between?
Negative 2 and 5.
Negative 2 and 5. Brackets or parentheses? Brackets. So that would mean we can be less than or equal to negative 2, x, and again, less than or equal to negative 2 to 5 is what you said. Okay, we'll graph that. Looks like I need to be able to see a little bit more graph. I need to be able to get to 5. 1, 2, 3, 4, 5. I need to go a little higher and lower. Do I want to try 10 again or 10 again? Oh, that's close on 5. I'm going to go to 20 just to be safe, and I'll stay consistent. Negative 20. See, the graph still doesn't cut off, does it? Darn. Well, I'm going to go higher until it cuts off. Let's try 30. There, it cut off, finally. All right, let's find our key values here. What do you see that we need? Zeros. Analyze graph. We'll go to 0. The first 0 is negative 1 comma 0 is what I'm getting. I'm going to do it a second time. Go to the left of the 0, click. Go to the right of the 0, click. That's our second 0. Do I only have 2 zeros?
No.
I have a third. I don't remember saying this in the lesson, but I'm going to tell you now. Whatever your highest power is, that's the maximum number of zeros. What's the highest power in this equation? The degree? 3. The most zeros you could ever have is 3. The most turns, or concave up, concave down, that you could have, it's called extrema, is 1 minus that power. Because to switch directions, you have to have a second power to switch directions once. You have to have a third power to switch directions a second time. So the turns that you might see is always at max 1 less than the highest power. That's how that works. Okay, now let's go to analyzing some, let's do minimums now. How many minimums do you see in this graph? If you said 2, you're correct. This is the one most students would get from here to here. Is that the only minimum?
No.
At the very beginning. Very good. Endpoints are considered maximum or minimums. They can be either one. I'm sorry. I was saying just by rule. They're either one or the other. Okay, and maximums. How many maximums do you see? 2. I don't have to. Draw an arrow on that one. Sorry, let me get it moved right. Okay, and finally last one. Maximum. Boy, there's a lot of stuff on this graph. Okay, so now I'm going to go Tools, Screen Capture, and we'll start filling in our information here. What was the question? That is that point right there.
That would be
Okay, so let's start with, we'll go across the zeros. What zeros do you see? You might have already filled this in.
-1, 0, 4.
Okay, you need to make sure you put x equals. Make sure you have that. Relative maximum. Do we have any relative maximum?
No, we have an absolute maximum.
Yes.
No, we
We
do.
do. Where is it?
That -0.5.
Okay, good. I'm going to just say negative, well, I'll fit it in there. 528?
Yeah.
5, 2. That's so ugly. I'm going to have to switch over to my board here. I can write finer with this thing. It doesn't show up as big work for your eyes, but it is finer, so I can fit it in with this. Negative 0.528, comma 1.13. Okay. Do we have any relative minimums? Yeah, which one? -2, comma -12. Good. That one is not as low as that one. Okay, do we have an absolute maximum?
Yes.
Where is it? 530. Good. Do we have an absolute minimum?
That's 2.53 and -13.
All of these, were they points or intervals? Points. These values, if you remember, these are the intervals. Where is the graph decreasing? We're going off x's values. It starts decreasing before 0. Where's the maximum?
0, 5, 0, -0.
Okay, from negative 0.528, it's from that maximum, this relative maximum, to this minimum, it's decreasing.
-0.528 to 2.53.
Got it? Okay, is it decreasing anywhere else? No? Okay, what about increasing? Chris, what did you say there? It's increasing twice? Perfect. Where's the first interval it's increasing from?
-2 to -0.528.
2, yeah.
528. Okay, what do you do if you have two intervals?
You do the
Union. So it's increasing here or where else?
2.53.
Good. Is it concave up anywhere? Where is it concave up? Okay, where do we want to say the inflection point is? Around here? Do we want to guess on this? We're just going to have to guess for now. I would guess approximately in here. Would you guess somewhere in there?
Yeah.
Okay, so I want to write in, this is a inflection point. Now, if you wanted to find out where it is, you would have to go to the table, do the change of y divided by change of x, and you'd look from where is the graph. If it's concave down, would the average rate of change be increasing or decreasing in here? Decreasing, and you'd wait till you start to see it increase, and then you would know the exact inflection point. We'll just kind of assume here.
Just 1 and 2, I think.
We're gonna where are we gonna approximate that point to be?
1 and -3.
1, -3?
Yeah.
Okay, we're approximating that. That's why I did that little squiggly there. So it's concave up from where to where?
-1 to
1 to 5. Where is it down? And again, I'll do that little squiggly because we're not sure on the 1. Maybe I should do the squiggly on the 1. Maybe that would be better. Okay. And what about concave down? -2. And again, I'm going to do this squiggly. What does that squiggly mean?
About.
Oh, yeah, about. Okay, and the inflection point? 1, -3. Now there's a way of technology of finding this out, but I'll play around with it a second. I don't want to play around with you right now when you could be working. So I'm going to do one more, and then I'll let you work, and I'll play around and maybe come back for it. Last one. Or do you think you have it?
Keep going.
If you want to start your DOLs, you can. For those who want one more practice, I'm going to do it one more time. 4x squared minus 4x to the 4th. Oh, one question before I let you go. What is the degree of part D? What is the degree here? 4. It's 4. So what is the leading term then?
2, 4, 1.
X squared.
Haven't heard the right answer yet. I've heard 4. I've heard x squared.
2.
It's the leading term is negative x to the 4th.
Right.
So what's the leading coefficient?
1.
Not positive 1.
Negative 1.
Negative 1. There you go. Okay, let's graph this and we'll finish it up. If you want to go to DOLs, you can. 4x squared minus x to the 4th. 4x squared. X squared minus x to the 4th. And I forgot my restriction. Anybody who's following along, -3 to 3,
Yes.
and there are brackets again. All those symbols, the vertical line and the inequalities, are found in the control equals button. I don't have to go higher. I do need to go lower. Ooh, I need to go even lower. Lower. Oh my. There we go. I am going to go higher just to clear the screen a little bit. No. I'm going to go a little bit higher just so I can have some room to paste. Okay. I'm going to go analyze my values. So I'll start with zeros. I see 3 zeros. I got one at -2. I have one at +2. And it appears the other one will be at 0. I have maximum. What type of maximum? Global or relative? Does the graph get any higher than that point? So we would call it global, or you could call it absolute. So the words they could use is global or local, or if it's the very highest, they could say absolute or global. So local or relative means it is a max or a min, but not the highest. Absolute or global means it is the very highest or the very lowest. Man, a lot of points in this graph. All right. All right, the zeros. What'd you put for zeros here? Perfect. A relative maximum. Do we have any relative maximum?
No, we haven't.
No. I'll just say absolute, ABS. Okay, do we have relative minimum?
No, we haven't.
I do actually have a relative minimum.
Oh, what do you do? 0, 0.
0, 0. Very good. Very good. Absolute maximum. I have 2. Negative 1.41, comma 4. And 1.41, comma 4. I have 2. You would separate those with commas. You don't do a union. That's for intervals if you do a union. Absolute minimum. Negative 3, comma, negative 45. And 3, negative 45. This is symmetrical. You'll learn that this is called an even function, symmetrical on the y-axis. Where is the graph decreasing? I see 2 intervals it's decreasing. Nah, it's increasing still right there. It's from the maximum. It's from
Negative 1.4 to 0.
1.41, comma, to 0. Good. And remember, these are intervals. Union. Good.
Negative 1.41 to 3.
Got it. That's the decreasing. Where is it increasing from? You got it that time. Yeah, good job.
I be looking at it in the numbers.
Yeah. And then it's increasing from this minimum to this maximum. From 1.41. All right, good. Concave up. Is it ever concave up?
Yes.
So it'll be somewhere in here to in here. Let's just approximate this. So I'll switch colors. We're going to say it's concave up. Let's just use from, you want to say negative 1 and positive 1, just to be simple. I'm going to do the squiggly outside because both of these values are rounded. And what about concave down? Negative 3, comma, I'm approximating the negative 1, the negative 1. Whoops, I forgot to put the negative there. Sorry, concave up from negative 1 to there. Okay. That's that concave down, and this concave down would be from 1 to 3. So those are intervals. That's why they get unions. And then finally, inflection points. How many inflection points are we going to say? 2. Just going to say approximately. I'm just going to say negative 1, and what height do we want to say that is? 2? 1, 1.5? How about 1.5? Looks like it's somewhere in between 1. Yeah, I'll say 1.5. There's 1 point, and the next would be 1 and 1.15. Whoops, 1 and 1.5. This would not get a union because that's a point. You separate points by commas. Intervals get separated by unions. All right. You have a couple DOLs to work on now, and I'll come around and check those. Some things I have not said yet that are going to come up that's important. You can tell that this is an even power. Do you know how I know it's an even power? Okay, if it's perfectly symmetrical, that means you only have even powers. We're going to learn that. But you see how both the left piece and the right piece are both going down? If they both go down and they both go up, like a parabola, that means the degree is even. If one goes up and one goes down, the degree has to be odd. So if you real quick through the ones we've done. First one,
Odd.
whoops. Change. There we go. This one. See how they both go up? The degree is even. This problem, 1 goes down, 1 goes up. What does that mean about my degree? Odd. Here, what's my degree? Just look at the equation this time. 3, which is odd. You see how 1's going down, 1's going up? So those are things that we're going to learn in the future. But I'll let you do this DOL and this DOL. Okay?